So what we're going to do today is just kind of talk about some ways to prevent some of this stuff, and also how we're going to build some safer, storage sites in the future. And Carol's going to share some thoughts on grain conditioning and how do we keep this grain from spoiling. But if you look at the history of the grain industry, back in the early 1800s, grain was just put into burlap bags and put in a warehouse, or flour was put in 100-pound or wooden barrels. And then towards the late 1800s, we started building crib elevators. And actually the crib elevators and the unloading legs and those kind of systems actually got started in Buffalo, New York, as we were shipping grain across the Great Lakes, and the grain got transloaded with wood crib elevators in Buffalo and loaded onto barges and wagons and rail cars and shipped east in New York and Boston. A lot of these conveyors and the techniques we use today actually got developed in Buffalo and New York, of all places. But then in around 1900, P.D. Grain started playing around with some concrete tanks, and in 1908, Butler is no longer in existence today. Brock bought out the Butler company, but Butler in 1908 took the same materials they were making cattle water troughs with, and they started building grain bins. So anyway, we see a lot of the changes here. We saw then around that, of course, in the early 1900s, we started seeing grain bins pop up on farms. And of course, back in the 50s and 60s, we got away from the ear corn, the combines came on the scene, and we started seeing grain bins show up on farms instead of the crib elevators. But we've seen a lot of different types of steel bins come and go over the years, and there's probably been as many as 25 steel bin companies just disappear in the last 40 years. We've got roughly 7 today that probably make 90% of the grain bins in North America. So we went kind of from the crib elevators to steel bins to the concrete tanks. We kind of watched that transformation. And now we're using a combination of steel and concrete, and also quite a few outside piles across the Midwest. We actually have about 23 billion bushels of permanent storage in the U.S. and about 4 to 4.5 billion bushels of outside piles. And this relationship of farm to off-farm varies quite a bit when you go in areas like Minnesota and Dakotas as opposed to Oklahoma, Kansas, Texas. That relationship is quite different. But if you look at the entire U.S., a little over 55% of the total storage, the 23 billion, is on farms. Let me just go to the next one, Carol. This doesn't come through real clear, but again, what we've seen happen is the first steel bins were 12-foot diameter, maybe only about 10 foot high, and held maybe 1,000 bushels. Today we're putting up bins that are a real common bin in the Midwest is 105-foot diameter, and we're seeing more and more companies putting up 132-foot diameter, 155-foot diameter bins, and we're building sidewalls as high as 92 to 96 feet. So there's a tremendous amount of weight on the foundations, and we're actually seeing some of these bins collapse because people are kind of cheapening the construction, and they're not building the foundations they need to support that kind of weight. But so we keep seeing these bins getting bigger and bigger. Of course, we've talked about some of these numbers, and we're seeing the number of saves in terms of people who are actually rescued successfully from an entrapment. That number is improving because people are getting more serious about tying off and using harnesses and things like that. But roughly if you look at the last 20 years, 75% of the incidents happen on farms, and about 68% or 2/3 roughly happen in steel bins, and about the same percentage happens in corn versus other commodities like soybeans or oats or wheat or anything else. And a lot of that is because of the configuration of the bins. When you look at wood bins and concrete silo, unless they're awful big concrete silos, they've got sloped floors, and of course the steel bin, unless it's a small hopper bin for seed or feed or an overhead bin or something, the majority of the steel bins have flat bottoms with the emphasis on that center discharge hole. And also when you look at the construction materials, of course, wood bins and concrete and the way we build them in a cluster, a lot of times the R factor is different. There's more convection currents in a steel bin, and Carol will get into this, But anytime the outside temperature varies a lot from the temperature of the grain, there's actually movement of air in that bin. And Carol will talk a little bit more about that and what that does in terms of grain spoilage and stuff. So again, we've watched these bins get wider and much taller, and it's a lot of bins going up today are anywhere from 750,000 bushels in the bin to as much as 1.3 or 1.4 million bushels in one bin on the commercial sites. When that center discharge hole stops flowing, assuming that it doesn't plug before it gets to this point, which is another problem, and we've got way too many bins that are built with just a simple 12-inch hole in the middle and no options if that center hole plugs. But when that center hole stops flowing, there's probably somewhere around 12 to 15% of the grain still left in that bin. So if you have a 105-foot bin, there's over 100,000 bushels of grain left in that bin yet when that center hole stops flowing. Or in the case of an 80-foot bin, there could be as much as 50,000 bushels still in that bin. So there's still a fair amount of grain in that bin. If somebody came into the side opening and tried to walk down the slope of this grain and set up the sweep auger or try to unplug an opening here or something, there's still a lot of grain here that can get them in trouble. The other thing we're running into is this question of what's the realistic lifespan of a bin. And usually over the years you bought a steel bin and the manufacturer said that this bin is good for 35 years or more. Well, what happens when now it's 40 or 45 years? What do we do with that bin? Do we take it down or do we keep using it until it falls down? And we're seeing more and more bins literally fall down because you get in there and it's empty and you look at that first rung that touches the foundation and you can see pinholes all around that first ring of the bin. Do you keep using it? Do you keep using it until it falls down? What do you do? So we're getting more and more those kind of questions, and insurance companies are reporting more and more bins that are falling down every year. But these are some of the reasons we feel that we're seeing this high frequency of grain entrapments. The one issue is just the simple fact that we're growing a lot more corn. In the U.S. alone, we're growing a pretty typical year anymore in the last 5 years is 13, 14 billion bushels of corn. We're holding it for longer periods of time. We're holding 4 to 5 billion bushels of corn through the whole year as we feed the ethanol plants and things like that. And we're still doing a poor job of keeping the grain in condition, especially in farms. We don't take enough time to check the temperatures and run those aeration systems the way they're designed to be run. And most of the farm bins, especially the older, smaller farm bins, were put up when there's no temperature cables even in the bins. And we should be putting temperature systems in these bins and monitoring the temperatures. And when you see that temperature moving, even just a degree from time to time, that's telling you that there's something going on in that bin. But the bins are getting larger. The reclaim systems, when we talk about the reclaim systems, we're talking about the sweep auger above the floor, the size and the spacing of the discharge holes in the floor, as well as the auger under the floor. But we're looking at that whole system. We really want those systems beefed up and designed in such a way that there'll be a zero entry system that they'll unload the bin without anybody having to get into that bin. And so we want to be paying more attention to those kind of things and have a true zero entry system. The restraint systems, we'll talk about that a little bit, and we've got some demos out here in back that we'll show you today. But we want people to use a harness if they're going to be walking in grain where there's enough grain in that bin that could potentially entrap you. We want you wearing a harness and having somebody outside managing that lifeline when you're in that bin. And to that, what we're doing with the steel bin companies is asking them to put anchor points in the bin so you can fasten these bin entry systems and these lifeline systems. And we'll show you a little bit more about that. And the other thing we want to do is just encourage people to do more hands-on training. They really need, if you're sending somebody into a grain bin, you need to point out to them, take enough time to point out to them what are the hazards, potential hazards getting in and out of that bin. And do they really understand those hazards? If something goes wrong, do they know how to deal with it? But those are the kind of things we really need to get more serious about training. Again, we've gone from 13 billion bushels in the last couple of years, but when you go look back in the 1960s, we were only growing about 3 or 4 billion bushels a year of corn. So we've come a long ways, and we're producing well over 10 billion bushels more corn a year than we did 40, 50 years ago. Carol will talk about this in more detail, but these whole issues of making sure people understand these basics of keeping the grain in condition. If the grain doesn't spoil and it unloads itself the way it's supposed to unload itself, we're going to avoid a lot of these problems. But if you've got to clean the grain properly going into the bin, you've got to dry it properly, and then cool it down, again quickly, move that front through the bin, and monitor the temperatures on a regular basis. And Carol's has been a big advocate, and rightfully so, as the vents have been getting bigger over the years. We're not putting enough vents in the top of those roofs, and we need some powered exhausters at the peak so we can keep some air moving underneath these roofs and stop that condensation underneath the roof. That's always starts to be a problem. These flyers, I think there's a copy in your packet, and we've got some extra here. If you'd like some of these actual flyers, we can dig that box out. After you dig the box out, put it here if you want to grab some of these at lunch. But in this stop sign, we talk about these 7 best management practices. And usually when somebody dies in a grain bin and we go back and audit what happened, we find that in most cases they violated most of these steps here. They took some shortcuts. They came back and bit them. And so what we try to do with anybody that wants to spend some time with us, we'll talk about what these 7 best management practices are. Fred in the building next door is going to talk to you about your Ministry of Labor and how your Ministry of Labor looks at some of these things. I don't tend to get too focused on what the government thinks. I'm more concerned about you folks and the people going in and out of the bins understanding just very practical, what is the hazard if I get in this bin? And how do I deal with those hazards and mitigate those hazards? On the other side of this T-chart are what we call design parameters. And again, we're not going to spend a lot of time talking on it today. We'll touch on a few of these, but some of these include just doing a better job of conditioning the grain, putting in better access doors and better reclaim systems that are more user-friendly, more efficient. And a lot of this stuff, if you look at this website, if you go to this website, grainentrapmentprevention.com, and open that up, what'll pop up on your screen is this home page. And you can scroll on down, and there's probably 14 or 15 section titles underneath this. And you can open those up, link to those, and there's all sorts of additional PowerPoints and videos and other things like that on this topic if you want to take the time to study it in more detail. But again, one of the first things we talk about is just stay out of the bin. If at all possible, don't go into that bin unless you absolutely have to. And if we can do a better job of grain conditioning, using the aeration and temperature systems the way they're designed to be used so the grain's not going to spoil, and then putting in a reclaim system that's going to empty that bin effectively without you having to go into that bin and then end up with plugs and everything else to deal with. Those are really the types of systems and the mentality that's going to help us reduce some of these things. Of course, not working alone, and hopefully we have time to share that Roberta's request. That video does a nice job. She actually talks about her husband who died in a silo in Kansas and stresses the fact that all of us, we're all guilty. We're all in a hurry. We're fighting the clock. We've got so many more acres to get in before the weather changes, or we're trying to get this train loaded to meet the contract deadline. And we're always in a hurry. And when we get in a hurry, we do stuff that we don't take our time maybe to get the right equipment, or we don't take the time to get another person to help work with us the way we should. And so those are the kind of things that we need to focus on, more seriously. I could advance that, Carol. You want to go out there? Sure.
I'll be back.
Free up there. Again, not doing any of this kind of stuff unless you're trained. We want to make sure that people are trained to do this stuff effectively if they're going to go in and out. And one of the things that we really want to stress here is using a secured lifeline. Our OSHA, which is the same as your Ministry of Labor, will tell us with 1910-272, they've used this quote many, many times, but they've never told us how to do it. Is they've used the statement that you should have a harness on, you should have a lifeline, and that lifeline should be positioned in such a way that that individual in that bend will never sink below their waist. Well, how do you do that if that lifeline is not secured? You know, if you got an observer outside on a ladder or a work platform, and that observer's got that rope wrapped loosely around their hand, and all of a sudden they get an 800-pound jerk in that rope, what's going to happen? You know, I can think about 3 things, and none of them are good. You know, and so we're going back to the steel bend companies, and we're saying, hey, to use these bend entry kits, and we'll show you what those look like out and back. Fundamentally, to start with, we need an anchor point in that bend. We need something that's going to support, you know, a 1,200, 1,500-pound jerk. And so what we're doing, and we'll show you what some of these systems look like, all the steel bend companies have, in effect, agreed with us that anything built in the future should have anchor points in the bend. So whoever you buy a steel bend from in the future, you should insist that they don't leave your site until there's some anchor points in that bend. And we'll show you what some of these anchor points look like. The other thing, we won't spend a lot of time today talking about some of this stuff, but we encourage people to wear a decent harness. And most of the time, somebody will go out and buy a cheap $80, $90 industrial harness. But if, especially in the case of the firefighters, if they're going to get involved in any kind of rescue work, we want them to wear a good class 3 rescue harness, which has some better padding around the legs and has more D-rings that we can hook into for work positioning and other skills that we have to use. So I'd encourage you to think about buying maybe a better harness than maybe just a cheap industrial harness. The other thing we're getting into, and I'm not going to spend a lot of time boring you with some of these definitions today, but we're getting into with our OSHA and your Ministry of Labor and other people are some of these definitions. And why do these matter? Well, if you're on top of a bin, or you're working on the distributor or on top of the dryer or something else, and there's a possibility you could fall, we refer to those systems as fall protection systems. If somebody's walking on grain in the bin, we call those restraint systems or work positioning systems. And the difference is that a fall restraint system is preventing you from falling, while the fall protection is actually catching you as you're falling, and that makes a big difference. Are you free falling, or are you just preventing the person from falling? It makes a big difference in the type of anchor points that you're required to put in. And that was one of the things that the steel bend companies balked with us for years. We kept asking for these anchor points, and everybody was falsely under the impression that it was for fall protection systems, and they kept telling us there's no way they're going to put an anchor point in the roof of those bins that's going to support 5,000 pounds, which the Ministry of Labor and OSHA would mandate that that system has to hold if it's a fall protection system. So again, we want to make sure everybody's talking the right terminology. If we're in the bin and you're walking on the grain, it's fall restraint or work positioning. If you're on the roof or you're up servicing some of the spouting, well then it's fall protection. So we need to understand what the differences are between those two. What we're doing is we're putting in the anchor points in the roof. So that if somebody's walking around the grain, we've got a rope here that we can put in here, and we're hooking some of these knot-passing pulleys, and they come in a variety of sizes. This is a pretty common one that we started using in 2008 at Star of the West, but it's wide enough that you can put a pretty good sized knot through here and a couple ropes, and the system's not going to bind on you. And we just hook this carabiner into an eyebolt or something, just pass it around there. And we put that in the roof of the bin, hook it into a compression ring. This type of thing over here, if you don't have anything in the roof, you can support somebody, tie off, try to stabilize somebody out here, but it really is pretty difficult to effectively keep that person from sinking down in the grain unless you have a tie-off point up above, directly up above the person. And again, you want to keep the slack out of this rope. If you let this rope develop 6 or 8 feet of slack and somebody falls through a crust, then they're still going to end up getting engulfed. So we want that rope, the slack, minimized in that rope. And this is what we call a bend entry kit. And we've got some of these kits that we're making for commercial elevators as well as farms. The ones we give a farm, a family, are usually a little bit lighter, and we don't put quite as much rope in the bag. We may not put quite as much hardware into it. If they don't have a harness, we'll throw a harness in the bag. But this kit, and we'll show you how this works, you basically secure this system to an anchor point. And this anchor point really needs to be solid enough. We refer to it as a bomb-proof anchor, something that's going to support 2,000 pounds. And so you don't want to try to tie off on a piece of conduit or an aerating duct or a ladder rung. Most of your ladder rungs won't support that kind of force. And we're using a couple of pressings here that slide up and down this rope. So if somebody's on the other end of this rope and something happens, these pressings will automatically lock. And we'll show you how that works out there. These pressings are 8mm cords, whereas this rope is a 1/2-inch rope. And these are two different lengths. The outside one is usually about a 5.5-foot cord, 8mm cord, and the inside one is a 4.5-foot. So if that inside one fails, the outside one's going to grab. And it just happens unconditionally. You don't have to, there's nothing you have to do manually or trigger something. It just automatically lock if something happens to that individual in the bin. But these are the kind of systems, when you hear the term in the future, bin entry kits and systems to control the grain bin entry lifelines, these are the kind of components that you're going to be seeing that come on the market and made available to people, and we'll teach you how to use some of these systems, and so you get comfortable with the different things that you can use. And again, you can use anchor straps, or you can use 1-inch webbing. They both suffice nicely. These 1/2-inch Kermanto ropes, they'll support 9,000 pounds. It's amazing how much force they'll support, as long as you don't touch them against a sharp edge. You start throwing these ropes over the side of a bin, and you hang a person you're doing a rescue on, and try to lower that victim and the rescuer together down on the ground. If you have 500-600 pounds in that rope, and you rub that rope against a sharp edge, it'll snap. So you got to be careful of where that you have edge protection if you got that rope going over any sharp edges or anything like that. But we get into some of these basic kind of issues, and just again make sure everybody understands how to use these kits. Carol and I have both been very involved. She's been much more involved than I have with this American Society of Ag Engineers, which is a group that gets together and agrees, basically in the form of a consensus, that we're going to move the bar higher. We're going to improve the safety standards and design parameters. And it's a mix of people, including steel bin companies, academia, government, insurance people. It's a variety of people that are getting together and looking at the current design parameters. And the current set of parameters we're looking at, if you ask for this document from ASAB, you refer to it as X624 is the document you would refer to, and it gets into these design parameters. But some of the basic things we're really focusing on right now is making sure that anybody that builds a bin in the future gives you a couple of decent anchors in that bin. It also changes the design of the access doors and the work platforms. And then we're going to drill into some of these other areas in the next year or two, including reclaim systems, better lockout tagout mechanisms. If you want to lock out your reclaim system, how do you do that? And do you have something handy that you can effectively use to lock out the system? What kind of ladders do you have in the bin? I don't know what kind of bins you guys have or how old some of your bins are, but most of the bins I get into, if they're 15, 20 years old and the grain's been turned a couple dozen times over that period of time, most of the ladders are pressed right up against the wall. The ladders are not built heavy enough to stand the kind of turns that we're putting through these bins. And when that rung is right up against the wall, and it should be 7 inches away from that wall, how do you effectively use that ladder? And so we're getting into ladders, signage, aeration systems, as well as equipment manuals. Some of the steel bin companies are doing a pretty nice job of leaving the new owner with some operating manuals, with the information we want to see included in those manuals in the future that hasn't been included in the past. So again, what we settled on was this issue of the steel bin companies and ourselves agreed that in the future, if anybody builds a steel bin, there'll probably be at least 2 anchor points in that bin. one near the eave and one around the compression ring up on top. And those anchor points will support as much as 2,000 pounds if the system is tested. We're also looking at access doors and entry points in terms of the size and configuration of some of these doors. The problem with a lot of these doors is they're just not real user-friendly when you try to get in and out, especially if you try to get any rescue equipment in and out. If you try to get a rescue tube in some of these bins, or a Stokes basket, or any of that kind of stuff, they're very restricting to what you can get in and out of that bin. And it's not just grain entrapments. You know, somebody working in the bin that has a heart attack or a stroke, and you have to package them and get them out. How do you get them out of there? You know, a lot of these openings are not wide enough to get the kind of equipment we want in and out of here. And usually at the widest spot of that door, what do you see? You see wind rings, you see ladders and that kind of stuff. So in effect, you know, you're working up here at the narrower part of that door, and we want to change some of that kind of stuff. So we're looking at the wider doors, and we're changing the configurations of these doors. The other thing we want to look at, and we were pointing out some of that to John and the staff out here this morning, and they did it right out here when they put out some of these GSI bins, most of them, but if you have a series of bins and you got a conveyor going across the top from peak to peak, where is most of these openings? They're right over here in the 3 o'clock position. Well, if somebody's down in that bin, maybe let's say it's a heart attack, you got to get in there, package that person, get them out of there. If there's nothing up above you here, you've cost us probably 45 minutes more time to get that person out of there, as opposed to if that opening was over here, a couple degrees off from center, so we can drop a rope straight down, pull the person straight out and drop them to the ground. But to create an anchor system here, that I can pull this person out of here and then turn around and drop them to the ground, just depending how fast you are and how many times you've done it, you've probably added 45 minutes to your rescue time with that door the way it's positioned. And so what we like to do is, and of course in some cases you're still going to have a draw spout here, so you're going to have a ladder to that draw spout. But if I put an opening here and here, and put up one ladder going up to this point and then step across, you know, I don't need a ladder up on every bin. You know, I might use a common ladder for 2 bins and hook them together with a common platform and put one hole here and one hole here. Now you've cut my time, my rescue time down by 45 minutes. And that makes a big difference if somebody just had a stroke or a heart attack or whatever, and you're trying to get them out of that bin. So we're asking the contractors to give a little more thought to where that top hole is. The other thing we want to do is we want to have better doors that you can get in and out of. And if that bin is on an elevated foundation, we like to encourage the use of tunnels underneath, especially these big bins. When you get into 105 and 132 footers, a lot of those anymore are being built on an elevated foundation, and we want a 7 foot by 7 foot square tunnel underneath it. But if that bin, whatever that distance is from this step, a lot of the bins are built with a simple 18-inch step. If that step is more than 3 or 4 feet from the ground, we want a decent work platform here with handrails around it. Unfortunately at Star of the West, we put in a bin like this about 4 years ago, and it just had an 18-inch step here. And one of our younger employees, it was during the second shift during soybean harvest, it was kind of drizzling that night, and he was working by himself. He slipped off that step and fell off and broke his back, and he's permanently disabled. You know, and there's no reason why we can't put decent platforms out there so people can get in and out of these bins and more safely, especially if they're carrying equipment. I'm going to get away from these 18 and 24-inch holes. Depending on how old your bins are and whose bin you're using, a lot of these openings on the side were built over the years with as small as 18 to 24-inch holes. Well, do you know how that got started, a 24-inch hole? When World War II started, the military asked some of the universities, including Wichita University and a few others, to come up with the optimum size hole for sailors to move from one side of the ship to the other and to jump in and out of Army tanks and stuff like that. And the university told them that a 24-inch round hole is the optimum hole for a young 19, 20-year-old sailor to jump in and out of. Well, that's fine for a 20-year-old sailor. But how does that work for a 65-year-old farmer that's 250 pounds wearing Carhartts? That's pretty tough, getting in and out of these openings. So we're telling the steel bend companies to keep your round holes, out of our bends. If you want to put an extra hole on the other side of the bend for air, that's fine. But give us a decent door that we can get in and out of those bends in the future. So we want decent doors in the top and better doors in the bottom, in both cases. Work platforms, we want them to meet ANSI standards. And of course, reclaim systems, we want better size holes and spaced differently. Here's some Butler bends. These bends are 60-foot diameter. There's one hole in the center that's 8 inches by 12 inches. And when that hole plugs, what do you think happens? What are your options? None of them are really good. This company punched in a hole and stuck an auger in there to try to pull out the grain on this conveyor. And all they got is a handle here that opens up that slide gate for that middle hole. But again, we want companies, especially when you start getting into 60, 80, 105-foot bends, we want to see 2, maybe even in these 105-foot bends, most companies are putting in 3 or 4-foot square holes in the middle of that bend. And they might even be putting in another hole off to the side as an alternate hole in case the primary hole plugs. And then the intermediate holes from that center to the outside wall, we'd like to see 24-inch squares and maybe spaced no more than 8 feet apart. So we want to put in some better discharge systems. The thing you need to keep in mind too is these bends are built with very little tolerance. If you throw something at them that they're not designed for, the bend will come down. The bend and sidewalls are designed to take an equal pressure in one direction. If you start subjecting that bend to unequal pressures and pressures from the different directions, they will come down. And we're seeing more and more bends come down every year. Here's an example. If that center discharge hole plugs and you start opening up this intermediate hole off to the side, what happens to the sidewall pressures in that bend? They're no longer equal. Where you open up this hole, there's not as much pressure on this bend, sidewall, as there is on this sidewall. So you create a pocket in terms of the forces and pressures on that sidewall. And this also is the same thing that happens if firefighters are trying to cut into a bend and they only cut one opening instead of cutting multiple openings to equalize this pressure. You have an unequal force on that bend and you're playing with fire when that happens. And the bigger the bend is, the more serious that is. If you've got a 20-foot farm bend and it's only 16, 18, 20 feet high, that's one thing. But if you have a 105-foot bend that's 92 foot high, that's a real critical issue. Here's a bend in Georgia. The middle hole plugged, and one of the employees, without checking with the manager, opened up an intermediate hole and said, well, the middle hole won't flow anymore, so I'll go down here and open up a side hole. These pictures were taken in the course of 2 hours. That's a bad hair day, guys. That's a bad hair day. And the other thing we tell the firefighters, when you start doing some stuff around a bend, and you start seeing some of the corrugations change, or you hear some bolts popping, you better be backing off, and you better look where that grain is going to go when that bend comes down. But if you take the height here and multiply that by 4, that's where the grain is going to go. If you have an 80-foot eave and that bend splits, that corn is going to be out there 300 feet from that bend, that sidewall. There's a tremendous amount of pressure in those bends, and when that grain comes out, it's going to flow out at a 21-degree angle of repose if it's dried corn in good condition. It's going to cover a lot more ground than 100 feet. And it's going to take down anything that's in its path, elevator legs, dryers, anything that's sitting alongside it, an office, it's going to take that stuff right off its foundations and that bend lets go. We had a I went to a training exercise we did in North Dakota 3 years ago at MineDOT North Dakota, and these guys just put up a 105-foot bend. They filled it one time, and I won't fill in all the details, but the company that put it up did some stuff and tried to cheapen up with some bolts and a few other things, but the bend blew out that night, and the rail cars that were sitting alongside that track, next to that bend, it blew the rail cars right off the track. So there's a fair amount of force when those bends let go. So again, we're trying to encourage everybody, put in bigger discharge sump holes. What does that cost you? And somebody will say, well, I don't have a big enough conveyor to support that kind of flow. Well, you don't really need that kind of conveyor size. We create a transition so that we can go in there and pull out the lumps in the tunnel, or another way to get the lumps out. But we want at least this discharge sump hole to be decent size, and use some decent sweeps, and of course a lockout tagout system. Then we can lock out the equipment. One of the first things we want to do if anybody is trapped in a bend and somebody shows up at the scene is to stop the flow of the grain. Stop any conveyor systems that might be running. If the person's completely engulfed, we want to turn on the aeration system and try to help the person breathe easier if they're under the surface of the grain. We want to do some of those kind of things to help our odds of saving that person. Manuals, we want to encourage the steel bend companies to put together better manuals that go into some of the issues here that we want to be stressing in the future. But again, this is kind of an illustration about the grain bend entry lifeline, and with an observer outside, a knot passing pulley underneath the peak of the bend, and the observer outside controlling the slack of the rope on the individual that's walking on the grain inside the bend. And we're using that knot passing pulley that you see. We started putting these in 2008, and we just put a couple of simple pieces of angle iron together and shackled them underneath where the truss and purlin meet. And you can either put them in here or up and around the compression ring. And we just leave a little cheap poly rope here that's looped around. It's just like a clothesline. It's like a simple clothesline from that anchor to the outside entry point. And when you want to use it, you just hook your lifeline into that, pull it up around, back over the knot passing pulley, and back out over here again. Hook in with your carabiner, and we'll show you how that is done outside into the person's harness. And then the other individual, the observer, mans the bend entry kit from there. So that all that tagline is to allow you to do that, to get that lifeline up around that pulley and back down again. So we're fastening these, either in where the truss and purlins meet, or we're bolting them underneath the compression ring to help that process. Some companies, including GSI, tried to put some systems in place years ago, and quite frankly, they were designed very well, but they weren't. They were not really cost effective. Nobody's going to pay an extra $10,000 or $12,000 for one of these systems. If I put an anchor and a knot passing pulley up in a bend for $150, somebody might pay me for that, but they're not going to pay me for $10,000 or $12,000 for one of these systems. And so that's what we were running into. So we're trying to. The other thing you need to keep in mind is these SRLs. There are some companies that are trying to use these SRLs, and for people walking around on grain. That SRL is only effective if somebody is free falling. If you fall off a rail car or you fall off a structure and you're free falling, that SRL will lock. But if you're so slowly sinking into grain like quicksand, that system won't lock. You have to be falling at least 4 feet per second, or that system's not going to lock. So some people feel like they're safe if they're hooked into an SRL, but that system's not going to lock. It's not going to help you if you're slowly sinking into the grain. Again, we touched on this earlier. The difference between a fall prevention system and a fall protection system. There's quite a difference when you ask the engineer to create a system with a maximum force of a couple thousand less pounds. Here's one thing that's, I'll show you just an example of a couple things that some of the steel bend companies are doing. Sioux steel is using a piece of angle iron like this and putting it across the top of the entry hole with a little shackle here that pivots, and you can put in your system, hook it into that. So they're using that piece of angle iron as a system that you can bolt into with your band entry kit. Global Industries is using a U-bolt over here near the eave and using the stiffener outside as a support, and then up at top around the compression ring they're putting another one up here. So a lot of the companies are either going with a U-bolt like Global Industries is doing here, or Sioux Cup is using a 2-inch eye bolt, but they're providing just very simple techniques and anchors that you can hook your bent entry system into. The other thing some of the companies are doing, if you have concrete storage, you know, if you look on top of your facilities, even if it's concrete, you look on top of a lot of concrete elevators, there's nothing up there that you can use for an anchor point. If you look around and you ask yourself, what can I tie off on that'll support 2,000 pounds? And you're not going to use the handrail. You're not going to use a ladder rung. We're building these anchor plates and putting in a series of holes, excuse me, and a shackle here. We're putting 2 of these plates in pairs on top of the concrete roofs. So the red is for the mainline system and the blue is for the blaze system, and it's a nice color coding system. And I would encourage you guys to, if you go through some of the classes that we offer and you learn how to use some of these rope techniques, one of the things you'll start asking yourself is, where can I create anchor points? If I need an anchor point in a hurry, what can I use? And so we're encouraging elevators to go back and develop anchor points that you could grab and use in a hurry for your raise and lower systems and different things. And there are some of these type of makeshift things you can use to hook into steel bands if you don't have something. This is a system that Carol's group worked with an individual down at Oklahoma State University called an Aspen lift that folds, and you can take up to the top of the band, open it up, and it'll sit on a sloped roof. Again, to pull somebody up and then drop them down on the outside and save some time. Here's some cofferdams that are available. I don't know if you're going to touch on that, Carol, or not, but there's probably 12 different cofferdams on the market. Some of them are wood, some of them are aluminum. There's one plastic one that's out there. Again, you have to ask yourself, you know, is this width? Is that too wide for me to get it through my opening? You know, don't assume that that cofferdam you're buying will go through your opening. Make sure you check it out. A lot of the fire departments are surprised when they find out that a lot of the openings in our bends won't accommodate a Stokes basket. So you have to use a skid, or you have to use some other kind of packaging mechanism. If you have to package that victim and get them out, is that equipment you're using too wide to get it out of the opening? But this is a nice, simple Baltic birch plywood type system. But with that, I think I'll turn it over to Carol.